Bismillahirrahmanirrahim. Assalamu alaikum. This is the second example on how to use Tmr0 to create a delay. In this example, the peak frequency is given to be 1 megahertz. That means, well, before that. And the timer 0 is set to run on internal clocking. That means the clock fed to the timer 0 before the prescaler is 1 megahertz divided by 4, which means the speed at the timer 0 before the prescaler is 0.25 megahertz. Okay, this gives me a T of 4 microseconds. 1 over 0.25 will give me 4 microseconds. Okay. Now the question is, how long will the program stay on this statement? Okay, timer 0 is set to run with a prescaler 16. That means the frequency entering timer 0 will be divided by 16. Timer 0 will start at the decimal 100. Okay, it waits until it reaches the value 151. So the time that is stayed here is equal to 4, which is T, multiplied by the scalar 16, multiplied by the number of counts, which is 51. That gives me a 3,264 microseconds, which is approximately 3.26 milliseconds. So the program will output 0F on port B for 3.26 milliseconds. Okay. How long will the program wait in this statement? Now notice that the timer 0 continues on counting from 151 and on. Here what I did is I switched the value at port B from 0F to F0, and then I waited for some time. This time is equal to 4, which is T, multiplied by the prescaler, multiplied by the number of counts that the timer took, which is 99 counts. Remember, it ended here with 151, and here it ends with 250, and that's 99 counts. And this gives me a 6.34 millisecond. So let me draw the output at pin RB0. RB0 here, it starts with a 1, and then it stays 1 for 3.26 milliseconds. So it stays 1 for this time. Then it goes down with this command to 0, all right? And it stays 0 for 6.3 milliseconds. And this is a while true condition, so it repeats itself. Okay, now let's see this working using the MPLAB. Discard. Okay, this is the program here. Now let me run the program. It stops at the first wait statement. It took so much time. 0 this number here, and remove the breakpoint, and let the program run from this statement to this statement, which is approximately the time taken to run this statement while get timer 0. Okay. Now it stops here. How much time did it take? 3.276 milliseconds, which is the time I showed you on the slide, almost 3.26 milliseconds. Now going back here and see the time running the other while statement. Remove the breakpoint and 0 this number. Okay, make a run until it's finished, and the output is 6.37 milliseconds. 6.37 milliseconds, which is almost the time that I calculated on the slide, 6.34 milliseconds. All right.